Morning, lads. As I said, I drew out these solutions for E. If any of you that did the questions that I posted up there for E. Okay, so let's look at the first question here. Question 8a, as it's given to you there on the screen that I gave you. Okay, the amount in appropriate units of a certain medical drug in the bloodstream, T hours, after it has been taken, can be estimated by the function. Okay, so let's scribble down the function. Okay, so we're looking at question 8 here. Okay, and the function is c to the t is equal to minus t to be cubed. Okay, so we know it's a cubic function, plus 4.5 t to be squared plus 54t. Okay, notice how there's no number or constant on its own there, so we can know that it's going to start at the point 0, or cut the y-axis at 0, 0. And then it gives you the domain. Domain is t from 0 to 9. Okay, now it says use the drug function, this is part A, or the drug amount function, CT, to show that the amount of drug in the bloodstream 4 hours after the drug has been taken is equal to 224 units. Okay, well, we're just substituting in 4 for t here in this question. So this is part A. So instead of CT, we're going to have C, and we're going to substitute it with the number 4. If this will work. There we go, 4. So it's going to be minus 4 to be cubed, plus 4.5, 4 to be squared, plus 54 times 4. Okay, so C to the 4 will be equal to 4 to be cubed, which is 4 by 4 by 4, of course, which is 64. That's minus 64. Okay, 4 to be squared is 16, so 4.5 times 16 is equal to 72. Okay, plus 54 times 4, which is equal to 216. Okay, so C to the 4 is equal to minus 64 plus 72 plus 216. Okay, which will give you 224. All right. So there, you've proven that, so it's correct. Now, B part. Okay, the B part here is use the function CT to complete the table below. So again, like I've taught you boys, you should plug this function into your calculator, okay, and then you'll be able to list out your coordinates, okay, to sketch your graph then for part C. So hopefully you've done that and you've gone into your calculator, and you can put in your T and then your output, which is CT. Okay, so we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and then your range, or your output value for each of those input values, should be given back to you from the calculator. I'll just use a different color biro here to show you that these are your outputs. You have 0, 0, which we would know from the start. Okay, 57.5, which it gave to us. Try and separate these. Okay, 118, 175.5. Okay, I should have given myself a little bit more space. So what I'll do is I'll stretch this out a little. So 4, 5, 6, 7, 8, and 9. Okay, 4 was 224, as we know from above. 5 was 257.5. Okay, 6 was 270. 7 is 255.5. 8 is 208. And 9 is 121.5. Okay, so that's the B part done. Hopefully you had no problems with that. So the C part then, okay, is you're asked to sketch this. And as you can see from the question, they've given you your y and x axis. So I'll do a quick sketch here of my y and x axis. Okay, so we're going across here as far as in 10 or 9. So 0, we go with 3 squares, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, we'll number those. Okay, and if you're happy enough with this as you can obviously fast forward on to the sections that you were struggling with. Okay, we'll go up in 2s here, I suppose. 25, 50. Okay, so we're going up in 25s. Hopefully we have enough space. Okay. Now, what we gotta do, lads, is plot our points. Alright. So we start down here, 0, 0. Okay. 57.5. Okay, and that's, I'm sure it'll be a lot more accurate than mine, lads. Okay, 218. 3 is 175.5. 4 is 224, should I say? Okay, and 5 is 257.5. Okay, and 6 is 270. Okay, and 7 is 255.5. Okay, and 8 is 208. And 9 is 121.5. Just below that there. Okay, we can sketch that there. Alright, and there you have your graph, lads. Okay. D, it says, use your graph to estimate each of the following values. In each case, show your work on the graph above. So very important as you show your work. Okay, the amount of drug in the bloodstream after 3.5 hours. Okay, so I'll use a different colour here, lads. I'll go with green. Okay, so this is your D part here. So you obviously want to go to time, which is on the bottom here. This is your time here, as given to you in the question. Okay, so you want to go to 3.5 hours, which is precisely here. Okay, that's 3.5. We bring your line up till it hits your graph. Okay, and we bring it across like so. Okay, now it does say use your graph there, so my graph might be a little bit off. Okay, but hopefully you'll get something, okay, in around 200 there. So we'd say 200 and, that's 5 maybe, or between 205, 210 lads. Okay, so D part 1, I'll just scribble it down here for you. Okay, so D part I, okay, I'm just going to use 205. Okay, D part 2 then, it says, how long after taking the drug will the amount of the drug in the bloodstream be 100 units? So obviously, go back here, use the green. We want to go to 100 here. Okay. And bring it all the way across. Okay, like so. Okay, and that there will be, drop it down here. So you're saying what? An hour and 45 minutes, give or take. Okay, so D part 2. Okay, 1 hour and say 40 minutes. Okay, moving on to part E then. So use a drug function, okay, to find in terms of t the rate at which the drug amount is changing after t hours. Okay, so obviously as the question goes on, lads, it gets a little bit harder. So again, it says use this drug amount function, okay, to find in terms of t, okay, the rate at which the drug amount is changing after t hours. Now, you wouldn't have done this with me just yet, lads. Okay, and this is your differentiation. Okay, but for the sake of it, I can teach you it now as we move along. Okay, but I can always go back to this and revise it with you when you go back to school. Okay, so basically what you do is you write out your function. Okay, and your function again, given to you in the question, okay, is c to the t is equal to minus t cubed plus 4.5 t squared plus 54t. Alright, now in front of that minus t cubed there's a 1, okay, which we know. Alright, so what you do then is you say it's 3 times that minus 1, okay, which will give you minus 3. Okay, that's going to be, so differentiation is c apostrophe t, it's minus 3 t, and you reduce the power by 1, so that goes to minus 3t squared. 2, okay, so that was 3 by that minus 1. Now we're going to go 2 by the 4.5, and 2 times 4.5 is 9. That's just t because you reduced the power by 1. So 2 minus 1 is 1. And again, the power there on top of that t is actually a 1. So 1 by 54 is 54. Reduce the power by 1, so 1 minus 1 is 0. Okay. So t to the 0, anything to the power of 0, lads, as we know, is 1. So therefore 54 times 1 is 54. And that there, lads, is your answer. So that's that function differentiated. Okay, but as I said, I know I haven't taught you this yet, but I'll just, for the sake of completing the question, I'll do it now with you. Okay, E part 2 then. So that's the rate of change there, lads. So then E part 2 asks, okay, use your answer to part E part I to find the rate at which the drug amount is changing after 4 hours. Okay, so really simply then, lads, you just substitute in. Okay, so, sorry, I'll use the same color here, black. So C dot, and it's 4 now. Okay, so it's minus 3 times 4 to be squared plus 9 times 4 plus 54. Okay, so multiplying that out, 4 to be squared, 16. Okay, and 3 by 16 is 48. Okay, 9 fours are 36 plus 54. Okay, add those three figures together. Oh, sorry, that's a minus there, isn't it? Yeah, okay, so it's a minus 48 plus 36 plus 54, and you get 42 units. Okay, and we're talking in rates of change now, so it's per hour. Alright, okay, so well done. E part 3 then, it says use your answer to part EI to find the maximum amount of the drug in the bloodstream over the first 9 hours. Alright, now, so what you do here, lads, okay, is you take down your function once again. So E part 3 here. Okay, so you've got your C dash T is equal to minus 3t squared plus 9t plus 54. Okay. Alright, and what you need to do here then, lads, is you need to factorize this function. Okay, because you want to find the max amount of drug in the bloodstream over the first 9 hours. Okay, so we let it equal 0 and factorize it. Okay, so when you want to find your max, lads, you have to let it equal 0 and factorize it. So I can divide across by 3 there. Alright, in fact I divide across by minus 3. So it's going to leave me with t squared minus 3t minus 18. Okay, factors of 18, that will give me 3, are 6 and 3. Okay, just get your signs right then. You want a minus 18, and you want a minus 3 in the middle, so it's a minus and a plus. So t will be equal to 6, or t will be equal to minus 3. We can discard the minus figure. So after 6 hours, okay, we'll be at your highest. Okay. Now, E part IV. Oh, sorry, no, they want to find the max amount of drug. Okay, so you substitute that back in, okay, to your original function, which is, continue down here. Okay, original function was minus t to be cubed, okay, plus 4.5 times t to be squared, okay, plus 54. So substitute in 6, okay, plus 54. Now, as I was writing that out, it just dawned on me that we have 6 already done up here. Okay, so if 6 is already done up there, we can already know the answer, which is 270 units. Alright, so you can come back there. You can see here that this is equal to 270 units. Alright, but that's the max amount of drug that will be in the bloodstream over those 9 hours. Okay, finally lads, we've got E part IV. And E part IV says, use your answer to part E part I to show that the drug amount in the bloodstream is decreasing 7 hours after the drug has been taken, and explain your reasoning. Alright, so what you do here is, once again, you take out your differentiated because it's rate of change. That's minus 3 times 7 to be squared plus 9 times 7 plus 54, which equals minus 30 units per hour. That there is a negative, so it shows that it's decreasing. That it is decreasing. Okay. So that was the first question I gave for your homework, lads. Alright. And then I gave you a shorter one then as well. So we'll do that question really quickly. And again, lads, if you want, you can fast forward on to the parts that you want to see. Alright. But the first question there, it was a question 8 again. A company makes and sells fiber optic cable. It can sell at most 200 kilometers of cable in a week. For a certain range of its product, of its production, the company has found that profit can be modeled using the function. So this is a profit function. So 275 x minus x squared minus 2000, where x is greater than or equal to 200. So it says, use the profit function to find out how much money the company loses if it does not sell any cable. Okay, x is the number of kilometers, okay, and px is the profit. Okay, so again, 8a, we'll just write out the function, which is p to the x is equal to 275x minus x squared minus 2000. Now, if you don't like the look of that, you can write it, okay, as a quadratic, and that's it, as a quadratic, if that just sits easier with you. Alright, now if it doesn't make any, well, x is 0. It's minus 0 to be squared plus 275 times 0 minus 200. Well, minus 0 to be squared is 0. 275 times 0 is 0. So your answer is they will lose 200 euro. Okay. Now, moving on. Sorry, that's the 2000 in the question. So they will lose 2000 euro. Okay, moving on to part B. It says here, in a particular week, the company made a profit of 8350. Find the number of kilometers of cable that is sold that week. So, what they've done there is said that your function minus x squared plus 275x minus 2000 will be equal to, because it's the profit, 8350. Okay, so what we do then is we need to solve for this. If we bring that over, it becomes a minus. So you get minus x squared plus 275x. Bring that over, you're going to get minus 10,350 euro equal to 0. Now when you have big numbers like that, it's always quite possible as, okay, that 275, okay, 10350, that you're going to get nice factors for it. Alright, so I'll give that a go here now. I want to change all those signs because I don't like the minus there, so it's x squared minus 275x plus 10350 equal to 0. Okay, bracket, bracket. Okay, so take 10350 on your calculator and start dividing in by certain numbers. I'll divide by 25 for first. I get 414. 25 and 414 won't make up 275. So it's got to be higher than that. So 10350 divided by 40. Okay, it doesn't go in. 10350 divided by 45. And 230, there we go. So 45. Okay, and 230. Okay, now look at the signs carefully. You want that to be positive. I want this to be a minus. So it's got to be a positive there. No. No. It's minus and minus. Okay. So we've got x is equal to 45 and x is equal to 230. So basically, okay, x, if you look very carefully at the question, x has to be less than 200. Okay. So therefore, it cannot be that. So 45 km of cable must be sold if they want to make a profit of 8350. Okay, C. So C then is just your typical graphing of it, lads. All right, which I'm sure none of you had any issues with, as you were doing them quite well in the class before we broke up. Okay, again, you have kilometers of cable sold, and down below you've got your profit, which is your inputs and your outputs. Okay, they want it from 50, 60, 70, 80, 90, 100. Again, I hope you put these into the calculator, boys. I'll use a different color once again. I've plugged into calculator already, and I have 9250. Okay, 10,900. 12,350. 13,600. Okay, 14,650. And the last one there then is 15,500. Okay. Now, the second part of that question then is you have to graph it. And once again, they've given you, okay, the axes. A little bit straighter. Alright, so they've got this squiggly line like so, lads. That means that you've just condensed it. Okay, that this is 0. Okay, you're not to worry about that scale. So they give you 9,000 here, and then they go up in the correct scale. Alright, so we can say every 2 there. Alright, so it's going 10,000. Okay, obviously much easier when you actually have the exam paper. You won't have to do this out. Okay, so because it's start 16. And then again, like so, we can start there, as that doesn't matter because it's condensed. And we go across in our 50s. And we go across in 4s, give ourselves a bit of space. Okay. Plot our points. Okay. Try to be as accurate as you possibly can, as obviously 10, 9, that there, 7 is 12,350, which is slightly below it. Okay, 80 is 13,6. That there. Okay, 90 is 14,650. There, yeah, about there. And 100 is 15,500. Alright. Okay, so now what we do is just sketch it, and you only start from the first quadrant, lads. You don't go back down to 0 because obviously that's been condensed. Okay, so it looks like so. Alright. Now, it says use a graph to estimate the lower and upper range of sales in kilometres of sale in order to make a profit of between 10,000 and 14,000 in a particular week. Show your workings on the graph. Okay. So what do you do there? Use your graph to estimate the lower and upper range of sales. Okay, so you're looking at sales. Okay, so from a profit of 10,000 to 14,000. Right. So if you go across here from 10,000, and you drop that down. Okay, and your upper is 14,000. So you go across, and you drop that down. Okay, that there will be your lower range, and that there will be your upper range. All right. So your lower range there, okay, you're looking at probably 55 kilometers, and there is in around, give or take, I'd say 83, 84. All right, we'll scribble that down here for you. Okay, so see part 3. This is part 3, isn't it? Yep. Okay, your lower is that. Okay, and your higher is that. All right, and finally, then on to D. Okay. It says use calculus. Okay, so this is your differentiation, lads, to find the number of kilometres kales sold when the profit is increasing at a rate of €105 per kilometres. Okay. So again, you take your function as we gave it to us in the question. Okay, so minus x squared plus 275x. So minus x squared, okay, plus 275x minus 2000. Okay, and differentiate that. All right, so that was px. So p dash x will be equal to minus 2x plus 275. Okay. We'll let minus 2x plus 275 equal 205. Okay, bring that 105, or that 275 actually, bring that over, it becomes a minus. You get minus 2x is equal to minus 175. Oh, sorry, it's 170, my apologies. Okay, and you get, divide both sides by minus 2. You get x is equal to a positive 85. Okay, so there's that answer, lads. Okay, so 85, and again it's kilometres that need to be sold to make a profit of 105. Okay, boys, so there's the solutions to those two questions that I gave you. So what I'm going to do now, lads, is post this for you and let you read it. As I said, lads, fast forward and rewind as you please. If you have any questions, just drop me a message on Edmodo or email me, and I'll post you a bit more work as well. All right, lads.